Hey everybody, and welcome back to Lesson 2 of the Real Numbers course. Just to remind you, my name is Mr. Nazelli, and I am still really excited to get a chance to talk with you today. So let's get started. In Lesson 1, we spent most of our time introducing the real numbers, and we came up with a good visualization. They are the numbers on the number line. We saw that they go on forever. There's no end to these real numbers. And then we spent a little bit of time focusing in on the whole numbers, a very special subset of the real numbers, just the numbers 0, 1, 2, 3, etc. Now, it turns out for the whole numbers, we laid out 5 things that you really need to master to be able to work with these whole numbers. And they are, you need to be able to read and write them. You need to be able to count with them. You need to understand all the individual decimal places and how the structure works within all those different decimal places. You need to know how to approximate whole numbers, get kind of a number sense of how big or what numbers are close to. And then last but not least, you need to be able to operate on these whole numbers. You need to be able to add, subtract, multiply, and divide them. And that's it. Today, I want to build upon what we talked about yesterday. I want to stick with a very special thing that has to do with multiplication. Okay? So let's get to it. Let's get into that. We're ready for the huge fact of the day. You ready? The huge fact of the day is that every single whole number can be factored. Every whole number can be factored. Well, what does that mean? It means that it can be written or broken down as some number times another number. For example, let's say you wanted to factor the number 12. Well, there are many ways to do it. One way is to write it as 12 equals 4 times 3. 4 times 3 is a way to write the number 12. I should tell you that that's not the only way. If you were thinking about a different way, like maybe, 6 times 2, that's perfect. Okay, so there might be lots of ways to factor a particular number. But here's one. We've done what they asked. We factored the number 12. Just a little bit of vocabulary. 4 and 3 are both called factors of 12. And if you focus in on 4, that's a factor of 12, then 3 is called its companion factor. And 3, if you're starting with it, then 4 is its companion factor. Okay? So let's do another example. And they're going to ask us to do something slightly different. This time they want us to give them a bunch of ways to factor the number 40. So let's start listing out different ways of factoring 40. Well, I think what's really important is to know that automatically you can write down 40 as 1 times 40. That's automatic. People might think, well, okay, that's kind of like the lazy approach to factoring. No way. That is beautiful. In fact, here, just in case you were thinking that, I'm going to put a heart there because that's my favorite. All right, it's automatic. Every whole number someone gives you, you can always just immediately put down 1 times 40. Okay? All right, so let me open it up to you guys. Just shout out a different way of factoring 40. Just yell it out, and let's hear what you got. Ah, yes, good, very nice. Did you guys hear that? 40 can also be written as 2 times 20. Excellent job. 2 times 20 gives us 40. Nothing to it. All right. Good. Yeah, how about you? No, behind her. Yes, yeah. Next. No, the other side. Yeah, you. Good. 40 can also be written as 4 times 10. Very nice job. Okay? It's another way to factor 40. Last one. Shout it out. Scream it. Good. 8 times 5. Wait a minute. Is that the last one? Is there another way to factor 40? Take a moment and think about that. Did I mess you up? Did I lead you astray? When I said it, you need to write it as one number times another number, I think I might have led you astray. How about that? It doesn't just have to be 2 factors. It can be 3 factors. In fact, 4 times 2 times 5, if you look at the line right above it, can you see how 4 times 2 is really just a way of factoring 8 in that other factorization, in that other way to factor 40? And then we keep the times 5. So yeah, that is a perfectly good way to factor the number 40. Excellent. Very nice. Very nice job. Let me just check it just to make sure. 40 equals 32 plus 8. What do you think about that? Is that, first of all, is it correct? Is it a true statement? Is 40 equal to 32 plus 8? It is. But the million-dollar question is it a factorization? Is it a way to factor 40? Good, good. I can hear your brains humming there. Exactly right. That addition symbol, no good. When you factor a number, it's got to be all multiplication. So even though 40 is 32 plus 8, that is not a way to factor 40. Okay, good. One last thing, it's related to this. If you ever needed to list all the factors, if you needed to give that list of all the factors of 40, well, we just run down the list here and put down all the numbers that we see as factors in any of those expressions that multiply to give you 40. So like, for example, there's 1 there, there's 2, there's 4, there's 5, 8 appears, 10 appears, 20 appears, and 40 appears. And as a matter of fact, just notice that we see the companions 4 and 10, 5 and 8 that you see over here in those factorizations, in those ways of factoring 40. Okay? All right, here's a little bit of a challenge. 13 is a factor of 143. They tell us that. What they want to know this time is, what is the companion factor that goes with 13? And you might already be thinking, well, you know what we can do? Why don't we just divide to find that other factor? And I think that's a great idea. As a matter of fact, let's take 143 and see how many times 13 goes into 143. It's a factor, they tell us that, so that means it has to go into 143 evenly, no remainders. As a matter of fact, to say that 13 is a factor of 143 is the same as saying 143 is divisible by 13. Okay, it means it goes into it evenly, no remainder. Okay, so let's check that out when we do this division here. 13 goes into 1. No, it's too small. 13 into 14 goes 1 time. Put that down and subtract. 14 minus 13 is 1. I'll bring down that 3. So 13 goes into 13 1 time. Subtract that, and look at that. We do get 0 remainder. That means 13 goes into 143 evenly, like we said. And look, up here, there's the companion factor. 143 is equal to 13 times 11. So there's that companion factor. Okay? Wait, before I leave you today, I just want to point out one quick thing. Can you remember that lazy person's approach to factoring that we mentioned in the earlier slide? Where you take the number and just write it as itself times 1? Well, there are whole numbers where that's the only way that you can factor it. And that turns out to be pretty special. In fact, we give them a name. The numbers that can only be factored as itself times 1, as themselves times 1. Another way to say it is the numbers that are only divisible by themselves and 1. We call them prime numbers. Numbers greater than 1 that are only divisible by themselves and 1. Okay, those are the prime numbers. So why don't we take a second and see if we can figure out of the whole numbers, at least the first few whole numbers, which of them are prime? Well, if you remember the definition, it says it's a whole number greater than 1. So right off the bat, guys, I'm going to cross out 0 and 1 because we have to be greater than 1. So 2. What are the ways to factor 2? If you think about it for a second, it's only 2 times 1. It's only that lazy approach to factoring, right? 2 is only divisible by itself and 1. So 2 is a prime number. How about 3? If you think about it for a second, yeah, the only way to factor 3 is 3 times 1. That's it. 3 is also prime. 4? Wait a minute. I can do 1 times 4 to factor 4, but I can also do 2 times 2. So no, 4, because 2 also divides 4. 4 is divisible by 2, and not just 4 and 1, by 4 and 1. 4 is out. And I want you guys to notice something. Every other even number is also not going to be prime. Can you see that? Every even number can be written as 2 times some whole number. So every other even number except 2 is not prime. So we can go through and cross out all the even numbers, right? 10 is divisible by 10 and 1, but it's also divisible by 2, right? 10 equals 2 times 5. So it's out. That happens with all the even numbers except 2. 2 is the only even prime. Okay, it's pretty special. It's the smallest prime, and it's the only even prime. All right, if you go through the others, you'll find that yes, 5 is a prime number. 7 is a prime number. Is 9 a prime number? Good, I hear a bunch of no's. Make sure you're screaming this really loudly, okay? I mean, the neighbors should know. Don't be shy. No, 9 is not prime because 9 can be written as 3 times 3. That's a different way of factoring it besides the automatic one, 9 times 1, 1 times 9. So no, it's not. 15 is also not prime. In fact, the ones that we have left here, those are the first few prime numbers. Okay? What I'm saying is there are the prime numbers, the start of that list. 2, 3, 5, 7, 11, 13, 17, 19. 2, 3, 5, 7, 11, 13, 17, 19, and they keep on going. I'm going to let you guys think about some other ones. All right. With that, I think we'll call it a day for today's lesson. Now, we've got a fairly heavy question to answer tomorrow. See what I did there? That's what we'll get to in lesson number 3. We will ask ourselves, what about these numbers to the left of 0? I'll see you then.